When most people write code with AI, they paste an error into a chat, get a fix, and paste it back. That works for basic scripts. But when you try to build massive, interconnected systems, the single chat window begins to fracture. The large language model tries to hold the entire architecture in a single thread. As you feed it endless patches and stack traces, it loses track of the structural logic. Variables clash, dependencies break, and the AI forgets decisions it made 10 prompts ago. This is context collapse. You end up trapped in the middle. You try to act as the high-level system architect while simultaneously functioning as a syntax debugger, copy-pasting code blocks back and forth. You become the slowest, most error-prone component in the loop. Structuring a multi-agent system like this requires a hard separation. To maintain logic across thousands of lines of code, the human must be removed from the logic loop. Relying on a human-driven, conversational trial and error process doesn't yield a cohesive system. It yields fragile, chaotic fragments of code that eventually fail to integrate. To build a robust trading system, I divided the operation into two distinct layers. Strategy and execution are entirely decoupled. The first layer is the architect. Operating purely in the browser, this node is strictly forbidden from accessing or writing code. Its sole purpose is strategic control and data analysis. It ingests a massive volume of historical performance metrics. Over 40 development sessions, it processed the logs of 2,961 live trades and 5,308 labeled token outcomes. This scatterplot tracks token metrics at the exact moment of discovery. It shows that variables like token age and initial market cap are mathematically identical across both winning and losing trades. It is pure noise. But looking at the price change percentage at the 0-second snapshot shows a sharp divergence. The architect identified that entry signals are largely irrelevant. Exit velocity is the only reliable signal. Based on those hard numbers, the architect outputs clinical design documents and strictly formatted execution prompts. It doesn't write Python, it writes the rules. Strategic intelligence remains flawless only when it is kept completely isolated from the mechanics of coding. The second layer is the builder. This execution-only agent inside the integrated development environment reads the entire codebase and executes directly. It takes the strategic prompts generated by the architect and applies the actual file changes. It wires dependencies and resolves syntax errors mechanically, without needing to understand the broader market strategy. My role in this system was reduced to a data transport mechanism. I moved the prompt from the browser to the IDE, and then closed the loop by transporting the completion summary back to the architect. We maintained this strict protocol, design, execute, report, perfectly across 40 continuous engineering sessions. By repeating this cycle, the two disjointed AI nodes compiled a completely independent, autonomous trading system. The human user is no longer a developer. They act as a mechanical bridge connecting two superior synthetic minds. The result of this architecture is a multi-agent quantitative trading bot operating on the Solana network. Its core component is a velocity exit manager. Instead of using a static stop-loss, it calculates real-time price momentum. If a token accelerates rapidly, it widens its parameters to let the asset run. If volume collapses, it triggers an immediate exit, regardless of the current profit or loss. It also runs a self-calibrating feedback loop. Every 30 trades, it queries an external AI with its performance logs, then independently rewrites its own thresholds for buy velocity and acceptable momentum. It pulls in external market sentiment, using a fear and greed index as a Kelly criterion multiplier. When the market hits extreme greed, the system automatically reduces its capital allocation per trade to protect its vault. By separating high-level logic from rote programming, the dual-node architecture engineered a system capable of self-directed evolution and absolute emotional control. Across those 40 sessions, spanning thousands of lines of code, complex database migrations, and machine learning exit policies, 0 lines were written from scratch by a human. The standard model of assisted programming is hitting its limit. This project suggests a move towards synthetic orchestration. To study the exact architecture, read the session logs, or access the course module and the visual identity documentation, the links are below. Building this trading bot showed that when you separate the strategy from the code, the machine is free to engineer logic that stays structurally sound.